These are your notes for Unit 9, Day 1 of Pre-Calculus. If you would like to see the warm-up, review question, or any test questions we covered in class today, just look at the finished notes. So today we are going to talk about a new way of graphing on a new plane called the polar coordinate plane. So we're going to talk about how to plot points using polar coordinates and how to convert from rectangular coordinates, which are your typical XY coordinates, into polar coordinates, or from polar coordinates into rectangular coordinates. And we'll be able to transform equations between rectangular, which is your X and Y equations, into polar form. So polar coordinates. So when we talk about rectangular coordinates, those are the ones you are familiar with. So those are on the XY coordinate plane. So rectangular coordinates are your X and Y. Polar coordinates are R and theta, where R represents the radius of the circle that you're talking about, and theta represents the angle, or the angle of rotation, that we're talking about. So when we are graphing in standard form, remember we start and then we rotate up. So now that terminal side is going to be called our pole. So that is our pole. And the length of our pole, so if this is going to be our length right here that we traveled out, that's going to be the radius. And then the angle that we rotated up is going to be our theta. And then where we would normally call the x-axis, we call that the polar axis if we are on a polar plane. And so that point right there, instead of representing the point xy, it's going to represent our theta if we are in polar form. So for example, if this length right here is 2, then the radius of our pole would be 2, and then we rotated up pi over 4 radians. So that would be the point right here. That would be the point 2 for the radius and pi over 4 for the angle that was rotated. If we are going to talk about a negative radius, so if we are on a polar coordinate plane and we rotate it up pi over 4, so this would be pi over 4, and let's just say that that radius was 2. If we want to talk about a negative radius, what we would do is we would extend that pole in the opposite direction, and we would drop down, and that would be the point negative 2 pi over 4. So if the radius is negative, it represents movement in the opposite direction. So you can think of that radius more as a vector, and so it's the negative doesn't represent a negative radius, it just indicates the direction of movement. So here's an example. So if we rotated, so if we want to think about this as the normal y-axis, if we rotated 2 pi over 3 degrees, and then we went out 1, 2, 3, this could represent the polar coordinate 3 and then 2 pi over 3. Or if we wanted to do negative 3, 2 pi over 3, notice we would extend the pole in the opposite direction, and then that would be the point right here, would be negative 3, 2 pi over 3. Could we represent these using different angles or different radiuses? So if we rotated to here and came out to here, again, on the picture over there, it was 3, 2 pi over 3. Well, what if I rotated backwards? So this would be rotating 180 degrees or pi. And then if I want to rotate to 2 pi over 3, 2 pi over 3 would be 120. So I would need to rotate 60 more, so 60 past pi. So this is 3 pi over 3. So if I rotated negative 4 pi over 3, I would end up in the same location as 2 pi over 3. And then my radius, and then my radius would still be 3. So the point 3, 2 pi over 3 is the same thing as 3, negative 4 pi over 3. That's one way of getting there. We could also think about it as if this is 2 pi over 3, we could extend down here and then rotate down to here, which would be at negative pi over 3. So if I rotated to negative pi over 3, and then I had a radius of negative 3, that would put me back up on the other side as well. So let's plot some points. So the polar coordinates, or the polar plane, kind of looks like a spider web. And so if we wanted to do 3 and then 5 pi over 3, well, 3 would mean that I would be 3 out. So notice this would be a radius of 1, this would be a radius of 2, and this would be a radius of 3. So I would be on that third layer of the spider web. And then I want to rotate out 5 pi over 3. Well, 5 pi over 3 would be 300 degrees. So I'm going to start here and I'm going to rotate 300 degrees. So I would rotate down to here. And so that right here, this point right there would be the point 3 pi over 3. And so that extension would be the pole. Here is your polar axis. And again, this point right here would be the point 3, 5 pi over 3 in polar form. 2, negative pi over 4. So again, we would go and we would use the part of the spider web that has a radius of 2. And then if I want to rotate negative pi over 4, I would be rotating to here. So this would be my pole. And then that point would be the point 2, negative pi over 4. 3, 0. Well, if I rotate 0 degrees, I would start and end at the same location. So I would come out 3 for my radius. So that's radius 1, 2, 3. And so that would be the point 3, 0. Negative 2 pi over 4. So first rotate pi over 4. So if I rotated pi over 4, I would be here. And then I'm going to go out on my radius 2. So 1, 2. So that would be positive 2 pi over 4. And then remember, if you want negative 2 pi over 4, you just extend the pole, and then you go out in the opposite direction. And so this would be the point negative 2 pi over 4. What other polar coordinates would share the same point? Well, let's start with this point right here, 3, 0. So I could also rotate 2 pi and end up the same location. Or I could rotate 2 pi and then do negative. So this would also be 3 and then, negative 3 and pi. So if I rotated out to pi and had a radius of 3, so if I extended the pole, and this would be 3 and pi. Or if I did negative 3, I'd end back on the other side. So plot the point 3 pi over 6 and find other polar coordinates for A, B, and C. So 3 and then pi over 6. So pi over 6, we would rotate up to the first pole. So this is going to be my pole for pi over 6. And then we want a radius of 3, so 1, 2, 3. So that would be the point 3 pi over 6. Now, I want the radius for part A. I want the radius to be positive. Okay, so I still want a radius of 3. And I want my angle to be between 2 pi and 4 pi. Okay, well, if I rotate all the way out again, I need to end up at pi over 6. And so remember, a coterminal angle, we would add 2 pi. And so if I took pi over 6 plus 2 pi, I would end up at 13 pi over 6. So this is also the point 3 and then 13 pi over 6, and I would end up in the exact same location. So that is also 3 and then 13 pi over 6. And 13 pi over 6 is in between 2 pi and 4 pi. All right, for part B, it wants my radius to be negative, and then I want to be between 0 and 2 pi. So I want to be at the same point, but I need my radius to be negative 3. Well, for my radius to be negative 3, extend the pole. And then I need to be at 1, 2, 3. So I need to be at this point, and here I want the radius to be positive, and then I want to do the negative radius. So I need to know what angle I'm at. Well, this is pi, which is the same thing as 6 pi over 6. And so this would be 7 pi over 6 as an angle. So I want to be back over here. So to be back there, you would make the radius negative. And so I'd be at negative 3 and then 7 pi over 6. So 7 pi over 6 would bring me to this point right here. And then if I make the radius negative, it flips me across the pole to the side that I want. So that would be the point negative 3 and then 7 pi over 6. For part C, it wants the radius to be positive and then I want a negative angle. So for that, I want to rotate backwards. So I need to rotate all the way back to here so that I would have a negative angle. So my radius is positive, but I want a negative angle. Well, I've rotated 330 degrees in the negative direction. So that is going to be negative 11 pi over 6. So that is 3, and then a negative 11 pi over 6. Because rotating all the way back to 0 would be at 12 pi over 6. So I would be at negative 11 pi over 6. So those are different ways of writing the exact same point, 3 pi over 6. So how do we convert from polar to rectangular or rectangular to polar? Well, let's start with the triangle that we know. So if I rotated up to that point, that would be the point xy. And then remember, we went out x and we went up y, and then that would be the radius of our circle. So if I made a circle and you put a triangle in it, r would represent the radius of that circle. And then remember, we have SOHCAHTOA. And so the sine, and remember, angle goes down at the origin, the sine of our angle is going to equal y over r. And then the cosine of our angle is going to equal x over r. And the tangent of our angle equals y over x. Well, I want to convert from polar to rectangular. Well, polar coordinates, remember, are r theta, and rectangular coordinates are xy. Well, we're going to solve the sine theta equation and the cosine theta equation for x and r. Well, in sine theta, if I try and get y by itself, I'd multiply both sides by r, and I'd get r times sine theta equals y. So to convert from polar to rectangular or rectangular to polar, we need the equation r sine theta is equal to y. And then for x, multiply both sides by r, and r cosine theta is going to equal x. And so those are how we can convert from polar to rectangular. If you take r times the sine of theta, it gives you the y coordinate in rectangular form. And if you do r times cosine theta, it gives you the x coordinate in rectangular form. So those are two equations that should go in your long-term memory that you should memorize. So if we are given the polar coordinates, 6 pi over theta, so 1, 2, 3, 4, 5, we would go out even more. So this would be the point 6 pi over 6. If we wanted to convert that point into rectangular form, well, x is equal to r times the cosine of theta. So in this case, x is going to equal the radius is 6 because this is r theta. And then we would do the cosine of pi over 6. Well, the cosine of pi over 6 is square root 3 over 2. So x is going to equal 6 times the square root of 3 over 2, which would be 3 square root 3. So the x coordinate is going to be 3 square root 3. And then my y coordinate, well, to find y, you do y equals r sine theta. And so the y coordinate is going to be 6 times the sine of pi over 6, which would be 6 times 1/2, which is 3. So that point in rectangular coordinates, so if I put a rectangular coordinate plane over my polar coordinate plane, would be 3 square root 3, comma 3. So this is the same as 3 square root 3, comma 3. All right, so negative 4, negative pi over 4. So rotate negative pi over 4. And then 1, 2, 3, 4. So, and then flip it across because the radius is negative. So 1, 2, 3, 4. So that in polar form would be negative 4, negative pi over 4. And then to convert that into rectangular coordinates, you would take x equals r times the cosine of theta. So x is going to equal negative 4 times the cosine of negative pi over 4. The cosine at negative pi over 4, well, all students take calculus. At negative pi over 4, which is down here, cosine's positive, and cosine is going to be square root 2 over 2. And then if you simplify that, that would be negative 2 square root 2. And then to find the y coordinate, y is equal to r times the sine of theta. And so y is going to equal negative 4 times the sine of negative pi over 4. Well, sine is going to be negative there. So y is going to equal negative 4 times negative square root 2 over 2, which is going to give me positive root 2 over 2. So this point in rectangular form would be the x coordinate is negative 2 square root 2, and the y coordinate is 2 square root 2. So this point in rectangular form would be negative 2 square root 2, positive 2 square root 2. And then again, for a, that polar point 6 pi over 6 in rectangular form would be 3 square root 3, comma 3. So that's how you can convert from polar form to rectangular form. You need the two equations, x equals r cosine theta and y equals r sine theta. So what if we're given rectangular and we want to convert to polar? So find the polar coordinates of a point whose coordinates are 0, 3. Okay, well, we've got some equations down here that we're going to use. So one set of equations that we would use is r squared is equal to x squared plus y squared. So if we went back up to our original problem, notice that you have the Pythagorean theorem. So x squared plus y squared equals r squared on that right triangle. So that's where that's coming from. And then tangent theta equals y over x, which is what we had from up above, as long as the x coordinate is not 0. If the x coordinate is 0, then r is going to equal y, and the angle is going to be pi over 2. All right, so if we use this, we have r squared equals x squared plus y squared. And so we have r squared is going to equal 0 squared plus 3 squared. So r squared is going to equal 9, so r is going to equal 3. So for my polar form would be r comma theta, so it's going to be 3 comma theta. And notice since the x coordinate is 0, that means that theta is going to be pi over 2, which makes sense because if we put this on a polar graph, notice that the radius, if we put circles in, notice if we did this, the radius of that would be 3, and then where did we rotate it? Well, we rotated 90 degrees, so we would be at pi over 2. So the polar coordinate for the point 0, 3 would be 3 pi over 2. All right, so converting from rectangular to polar again. So let's say we have the point 2, negative 2. So 2 to the right and 2 down. So we're at that point on the rectangular plane. And we want to convert to polar coordinates. So we want to take that xy and convert it to r theta. Well, we start with r squared equals x squared plus y squared. So r squared is going to equal 2 squared plus negative 2 squared. So r squared is going to equal 4 plus 4. So r squared is going to equal 8. R is going to equal the square root of 8, or 2 root 2. So my point is going to be 2 root 2, and then we've got to find the angle. Well, x is not equal to 0, so to find my angle, we're going to do tangent theta equals y over x, so x and y. So it's going to equal negative 2 over 2. So the tangent of theta is going to equal negative 1. Well, you are down in the fourth quadrant, so all students take calculus. So here's my pole. And so we want tangent to be equal negative 1. And so for tangent to equal negative 1, we've got a couple options. We could be at negative pi over 4 if we rotated backwards. So this could be the point 2 square root 2 and negative pi over 4. Or if we rotated forwards to get to that point, we would be at 7 pi over 4. So it could be 2 square root 2 and 7 pi over 4. And so both of those could be the polar coordinates that would match to negative 2. All right, so why don't you guys pause the video and try to find the polar coordinates who would go with the rectangular coordinates negative 1, negative square root 3. All right, so negative 1, negative square root 3 would be probably about right here. So that would be where we would be, negative square root 3, sorry. We would be down here, so that would be where it would be rectangular. And we have r squared equals x squared plus y squared. So r squared is going to equal negative 1 squared plus negative square root 3 squared. So r squared is going to equal 1 plus 3. So r squared is going to equal 4. So r should be 2. So my radius is going to be 2. And then the tangent of theta equals y over x. So again, in polar form, we want r theta. So it's going to be 2 theta. And so tangent theta is going to equal the y coordinate over the x coordinate. So it's going to equal negative square root 3 over negative 1 or square root 3. And where does tangent equal square root 3? Well, at pi over 3. So I need the pi over 3 that would be down in that quadrant. And the pi over 3 that would be down in that quadrant. And notice it's positive. So we have, this would be 3 pi over 3. So I need 4 pi over 3. So this would be at 2 and 4 pi over 3. And that would be the polar those would be the polar coordinates that would match the rectangular coordinates, -1, negative square root 3.